Hi class. Last time we learned how to solve a right triangle. So let me first start by drawing a right triangle like this. Well, we have a right angle right here. As for labeling the angle, we call this one A, B, and this one C. And remember, in a right triangle, angle C is always the right angle. Okay. As for the side length, we will look across from each angle. So across from A, we have this side in here. We call it little a. Across from B, we have this side in here. We call it little b. And lastly, across from C, we have this side in here. We call it little c. Okay? What does it mean for solving a right triangle? That means that aside from angle C, which we know that is 90 degrees because it's a right angle, we have to know the measure of little c, little b, little a, and big B, big A. Okay? And remember, in order to solve for like all five of them, we have two big tools. The first big tools that I told you guys is A plus B plus C equals to 180 for triangle sum. And after that, because we know that C is a right angle, that means that C equals to 90 degrees, then A plus B should equal to 90 degrees, right? So this is one of our big tools in here. And the second big tools, when it comes to solving for either side or angle, you have to memorize SOHCAHTOA because we in a right triangle, right? SOHCAHTOA. So how can we apply this? So for example, let's say I'm aiming for angle A, right? Adjacent to A, we have little b, and opposite to A, we have little a in here. So by using so, we have side of A, big A, equals to opposite, which is little a, and then over hypotenuse, which is C, right? If I were to know big A and little c, I'm able to find A. How? Because side of A is actually side of A over 1, right? And then after that, we do cross multiplication. So C times side of A and then little a times 1. After that, we will be able to find A if that's what we're missing in the problem, okay? So that's for 9.1 today. Let's extend it. Let's talk about 9.2. So what if we're not lucky enough to have a right triangle, right? Like what if we have something that's not a right triangle? What if we have a common triangle looking like this? Like all angles are acute. Like this. Or what if we have something like this with an obtuse angle? Then what do? What are actually the names for it, right? So these case, whenever we don't have a right triangle, we call it an oblique triangle, right? So what does it mean by oblique triangle? Technically, oblique triangle, it means something like none of the angles are right, okay? So within a triangle, if none of the angles are right, it's an oblique triangle, okay? So some scenarios for an oblique triangle, like what I just said before, you can either have like all three acute angles, like the first picture, like this one, or you can have like two acute angles and one obtuse angle, or just any random like triangle as long as it's not right triangle, then it's oblique triangle, okay? As for labeling system, as before, we have three letter pairs. Angle A will go with little a, angle B will go with little b as for side length, and angle C will go with little c as for side length again, okay? They always look across from each other. And notice that because we're not in a right triangle anymore, right? We're in an oblique triangle, so C doesn't have to be right. C, in fact, can take on any measure as long as it's something like within 180 to fulfill the requirement for an angle to be within a triangle, then it will do, okay? For example, C cannot exceed 180, right? So just imagine you in a right triangle and one of your angle is like 200. That doesn't work, right? That doesn't even make sense because the triangle sum is only 180, right? So any angle measure within a triangle cannot exceed 180. Same thing goes for C, right? C is not like a right angle anymore, but it cannot exceed 180, okay? And just as before, to solve for an oblique triangle, it means that you have to find all three sides of the triangle. That means little a, little b, and little c. And we also have to find the three measures of all the angles, big A, big B, big C, okay? With that saying, I'm going to give you a new tool today, which we call the law of size. So what does the law of size say, right? It tells us that we're going to have three fractions. Why three fractions? Because in a triangle, the word tri means three, right? In a triangle, we have three angles, we have three sides, so we will have three fractions. Let me circle the fractions for you. Okay, and if you notice, a quick way to memorize the law of size is that they go in pair vertically, right? So the first fraction, side of A divided by A, as you can see, is the pair of letter A's. The second fraction, side of B divided by B, letter B. And then the last fraction, side of C divided by C, the letter C's, right? So we have the equation between all three of them. In general, law of size tell us that side of A divided by A equals to side of B divided by B equals to side of C divided by C, okay? In fact, you don't have to use like all three of them, but they just list them out in here, and you have the options of setting the pair of A's equal to the pair of B's, or setting the pairs of A equal to the pair of C's. It depends on what you have, and it depends on the problem, okay? You will see it in a moment when we actually do the problems, okay? So next on, what are the applications of law of size, right? So what do we learn it for? Like, why do we need law of size? In the scenario, for example, what if, okay, before talk about the scenario, a quick heads up is that for law of size, as long as we know at least one letter pair, what do I mean by one letter pair? You guys will see it in a minute. Then it will work. Okay, for all we need for law of size is just at least one letter pair. Like one letter pair will work. Okay, so let's talk about the three application, the three scenarios for law of size. The first scenario, let me put it in blue, this one in here. Okay, what if the problem gives us side C, angle B, and angle C? What do we do? At the first glance, you notice that we have one pair of letter C's in here, right? We know the angle C, and we also know the side length C. So what can we use in here? We know C and we know B, so we can set the equation something like side of C over C, because we know both of them, equals side of B over little b. Okay, since we know big B, big C, and little c, we do cross multiplication, and after that you will be able to solve for little b, right? And after that, since we know the angle since we know the angle B and the angle C, we use triangle sum. We take 180 minus B minus C, and then we will get angle A. And after that, you can pair A with either B or C to solve for the little a, okay, by using the law of size. Okay, and by the way, this case we call it side angle SAA, because in order we know side C first, angle B secondly, and then angle C. Like in the problem, it gives us like all three of them, but in order, like side angle. That's why we call it SAA. Okay. For the second scenario, let me put it in green. What if the problem gives us something like angle A in here, side C, and angle B? What do? At the first glance, we don't have any pair, right? And I told you guys for law of size, we must know at least one pair. So how can we know the pair in here? Like, how can we get anything to accompany with either A or B or C in here? So our big tool in here is the triangle sum. We know that in a triangle, A plus B plus C equals to 180. With that saying, to get angle C, we can do 180 minus A minus B, right? And after that, since we know angle C and we given little c, right? We have one pair in here. So you can set it up like side of C divided by little c equals to side of A divided by A. And since you know angle A, you will be able to find little a in here. And after that, if you want to find little b, you can do something like side of C again over C, because we know both c's, equals to side of big B divided by little b. And after that, we do cross multiplication, and then we'll be able to figure out the little b, okay? As for the last scenario, oh, by the way, the name for the last case, we call it ASA, because the order goes like angle, side, and then angle. Okay, so ASA we're talking about. And as for the last case, the last scenario, this one, SSA, the problem gives us something like side C, side A, and angle B. That's why we call it SSA in order, right? Like for side, and angle. So at the first glance, we know the pair of C in here. So with the same logic, we will go ahead and set it up like side of C divided by C equals to side of A divided by A, because we know the little a. And then after that, we do cross multiplication and we'll be able to find psi of A. And after that, we do inverse function and then we'll be able to find big A. Okay. So the takeaway from this one is, first, make sure that you know that A plus B plus C equals to 180 always in a right triangle. I mean, in any kind of like triangle. And the second takeaway is make sure you know the formula in here for law of size. Make sure you know how to set up each fraction equal to each other, and the hint in here, like I said earlier, is that the letters, they go in pair, right? So on the top you have big A, on the bottom it must be little a. And because we're talking about law of size, so for any angle that you're using in here for like in terms of fractions, make sure you attach the psi function to it. That's why we call it law of size, right? Because we need to use psi in here. And the third takeaway from this one is that the application for law of size is for when we have SAA, ASA, or when we have SSA in here, okay? So in the quiz or an exam, if I give you guys something like, can we apply the law of size in SSS? You guys will have to say no, logically, because in a triangle, if we have like three sides in here and we don't know anything about any angle in here, you cannot apply like any of these fraction, right? Because for each of the fractions in here, you need at least one angle, right? So if we know all three sides without knowing angle, we cannot apply law of size in here, okay? And if you guys want to memorize it, you guys can do it also. For law of size, we only have 3 cases in here, so SSS is obviously not one of the 3 cases in here, right? So you have to answer no in the quizzes or in the exam. If I give you something like, can I use law of size in case of SSS? The answer will be no, okay? All right, moving on to the problem. Okay, so let's talk about the first 2 cases in here where we have SAA or ASA. They put it together because these 2 cases are similar to each other. You guys will see it in a minute. And then our big tool, again, is a triangle sum. A plus B plus C equals to 180. Remember that sometimes you have to apply cross multiplication, especially when you're done setting up the 2 fractions equal to each other. And the last thing that I want to give you guys a heads up is that make sure your calculator is in degrees mode, okay? If it's were to be in radians, you screw, because each our angle measures in here are in degree, right? So make sure your calculator, it has to be in degree. Okay, don't set it up in radian. Watch out for it. Okay, let's talk about the first problem in here. So the problem gives us angle B equals to 10, angle C equals to 100, and little b, the side length B equals to 2. So right off the bat, we have one pair. We have one letter pair in here, which is big B and little b. And aside from that, we also know big C. So we're gonna go ahead and set up the fraction between the pairs, the pair of B and C. Okay, so it goes like this. Psi of B divided by B equals to psi of C divided by C. Okay, and after that, we plug in a number. We know that B equals to 10, little b equals to 2, and then big C equals to 100. We plug it into the formula that we just had, and then we have something like this. And after that, we're going to do cross multiplication. So then we will end up with something like C times psi of 10 equals to 2 times psi of 100. Okay, and then after that, you plug into the calculator. Psi of 10 is something, psi of 100 is like something again. And then you divide it over, you do the algebra, and then you will get little c equals to 11.34. Okay, and we know C already, so we need to know big A and little a, right? Big A, in my opinion, would be easier because we know the triangle sum in here, and we know big B, we know big C already. So let me put it in blue. According to the triangle sum, everything add up to 180. So the big A will be 180 minus B minus C, which means 180 minus 100 minus 10. So big A would be 70 degrees. Okay. Now that we have big A and we have the pair of B given from the problem, we can set it up like this, where we have psi B over B equals to psi A over A. Again, we plug in a number, we do the algebra, and then we will get letter A to be 10.82. Okay, so in the quizzes and in the exam, please box the answer like this. This is all I want to see. Like if you like, as you can see, right, it's like a mess on the inside, so it's really hard to tell which one is your answer. So it will be better if you make a little conclusion in here and then just tell me like what are missing from the problem. Like in here they give you 3 data, right? So you should have like 3 datas in your final answers. Okay, so if you can like box them and then just conclude it at the end, that will be easier for me to grade your work, and I will appreciate it. Okay, so keep that in mind. And I want you guys to try this example on your own. And just a heads up in here, we don't have any pair, right? Like we don't have little b to accompany with big B. We don't have little c to accompany with big C. And we don't have big A to accompany with little a. So how can we pop out like a pair in here? So notice that we have the triangle sum. So if we know big B and big C already, we'll be able to figure out big A. And from there, we have big A, we were given little a, we have the pair of A, right? So you can like set up any like fraction pair that you want to by the law of size, and you go from there to get little b and little c, okay? Try and let me know if that makes sense to you guys, okay? So now let's talk about the next case. Okay, SSA is known to be the ambiguous case because it's like you can never tell whether you have like no solution, one solution, or 2 solutions. And what I mean by solutions mean triangle. So for SSA case, sometimes you can have no triangle. For example, if you're solving for like angle C and your answer is something like 200, that doesn't make sense, right? That's what I mean by no triangle, because if some angle is not like within 180, if you have something like way bigger than 180 or even like slightly bigger than 180, that doesn't count already because that doesn't work for a triangle. Okay, so that's when we have like no triangle. Sometimes you can have one triangle and some other times it can create 2 triangles. Okay, so this is the tool that I give you guys, but honestly I never memorized these like rules in here. So my method is this. First step, you would have to solve for the easier angle, and I will talk about like what is considered to be like easier in a problem later on when we do the example, okay? But just for now, say if we were able to solve for angle A in here, like one of the 3 angle in here, what do we do after that? We have to find the supplementary angle of that. What is supplementary angle? That means they add up to 180. So for example, if I give you something like 10, the supplementary angle of it would be 170. If I give you guys something like 100, the supplementary angle of it would be 80. Okay? And at this point in here, if it makes sense, then you can tell like it's a good angle. Like if you give something like negative, then that doesn't make sense, right? And you can eliminate like A2 or like that supplementary angle that you just like found. And we will talk about it more when we do the example, okay? And the last step in here, after that, make sure you add up all the triangle. Make sure you add up all the angles to make sure that your triangle sum is within 180 or like 180, okay? If you were to have like 2 triangles, that's why we call it A1, A2, right? Like if we were to have like A1, A2, that means then the first triangle will go like A1, B1, and C1, while the second triangle goes like A2, B2, and C2, okay? Sometimes one angle can like can be represented in 2 triangles. You guys will see why in a second. I think that's what I had for your problem. In your problem, you should have 2 triangles, but for my problem, I will show you guys at the beginning. I were to have 2 triangles, but then I eliminated like one of them. That's why I end up having like just 1 triangle at the end. Okay, so let's dive into the first example in here. So right at the bat, we know that we have a pair of B, and we have the pair of letter B's in here, and we also know something about the side length of letter C. With that saying, we're going to go ahead and set up the fraction for pair A and pair C. After that, we plug in the numbers, and then we do cross multiplication, and then we end up having psi of C being 0.48, right? And after that, you will plug into the calculator to solve for big C. And just really quick in here, for this one in here, notice that you will not plug into the calculator psi of 0.48. This is wrong, okay? This is not it. So if I give you guys something like psi of 10, then when it comes to the calculator, you will do psi of 10. You will plug in the exact same thing, right? But if I give you something like psi of A, for example, equals to 10, when it comes to a calculator, you cannot do the same method, right? Because they don't mean the same thing. In fact, if you notice, there's a little a between the psi and 10, right? And there's also an equation like the equal sign between the word psi and 10, right? So that doesn't make sense if you just skip big A and the equation sign, the equal sign, all the way to 10, and just input psi of 10 into the calculator. That doesn't work. That doesn't make any sense for the second case, right? Instead of that, you will have to input psi inverse of 10. Okay? So notice, if there's no gap between psi and the measure, you do psi and then the measure, just like how it looks. Okay? If there's something in between psi and the measure, make sure you do inverse. Okay? And if you don't know how to do inverse, it should be on your calculator. Some calculator has like the shift function, so you have to do like shift psi. Or some other calculator has like second psi for inverse function. So if you're confused about that, if you don't know how to get to that, please email me. Okay? I'll try to find like a good video to show you how to do it. And if you remember, we already kind of like talk about it in class 2 in the last sections. I kind of like don't remember what section it is, but flip over your pages and you will find a page where I show you guys how to do inverse function. Okay, it should be within chapter 8, but I don't know which section it is. Okay, but just email me if you have any questions with like the inverse button. Okay. And after that, if you plug into the calculator psi inverse of 0.48, the first answer you will get is C equals to 28.8. Okay, this is what I mean by find the easier angle. Okay, why? Because, well, in this problem, in our problem, right, we know angle B, so the other two options would be either angle A or angle C, right? Angle A is really hard to find because we don't have anything that relates to A, right? Angle B is easier to find because at least we know the side length C, so then we can use a lot of signs to find angle C, okay? And after that, we call it C1, so we have C1 equals to 28.8. If you want to call it C, that's fine, but then later on you will trip over with like the notation issue. So just right off the bat, when it comes to this step where you know like the side value of angle C, the first answer, let's just call it C1, just to be safe, okay? And the second step in here, you have to solve for the supplementary angle of the angle C that we have in here. So the supplementary angle of C1 in here would be C2, where we do 180 minus C1, which is 28.8. And after that, we have 151.2, right? It's still under control. It's still like within 180. So C2 is still good so far, right? There's nothing wrong with it so far. Okay, and then I told you guys, like, sometime even if we have like two triangles in here, like some angles can be shared, right? For example, angle B in here, it would be shared. We're not gonna have like B1 and B2. If you want to think about it, B1 is also 40 and B2 is also 40, okay? Like they all the same thing. So we have B equals to B1 and equals to B2 in this case. We just don't write it out because they're just the same thing. So why would we bother to write B1 and B2? But if you want, you can do it. But for C1 and C2, because they look completely different, right? C1 is like 28 point something. C2 is like 151 point something. They are different, right? So that's why we have to have like different notation for it. We cannot just call it like C and C. That would be like more confusing, okay? And after that, we know the triangle sum. So we will go ahead and do step 3 in here, which summing for A2 and A1 in here. So A1 will be 180 minus B minus C1. and B in here is 40, C1 in here is 28.8. We solve for angle A1 and we end up having 111.2 degrees. Is still within 180. It's good. There's no problem with it. So that's good. For the second A, we have A2 equals to 180 minus angle B minus angle C2, which means 180 minus 40 minus 151.2. And we end up having negative 11.2. And in here, no side can be negative. No angle can be negative. So this one is a big no-no, right? That's why we're going to go ahead and eliminate angle A2. And that's why we're going to go ahead and eliminate that triangle with A2 or like C2 as well. So then for the final answer, we only have the first triangle, which has A1, B, and C1. And because we only have one triangle now, we can substitute the notation back to like normal A and normal C. Okay, you don't have to use A1 and C1 anymore because we only have one triangle in here. But if you were to have like two triangles, make sure you use a notation of 1 and 2. Make sure you use subscripts to tell you like which A is from which triangle and which C is from which triangle. Okay, so then at last, we have to find a little a in here, and we know the big A already, which is 111.2. We will go ahead and use law of size again, and since we know the pair B from the given of the problem, we will set up the equation like psi of B divided by B equals to psi of A divided by A. We plug in a number, we do cross multiplication, we do the algebra, and then we will get little a equals to 580. Okay, so the problem gives us 3 data. We must have 3 answers to fulfill like 6 measure in a triangle. Okay, we box them, we make it our final answer. That's it. Okay, so I want you guys to try this example in here by yourself, and like I said, I think this one is the case when you have 2 triangles. So try it and let me know if it works. Okay, let's talk about real life application. So with all that knowledge, how can we apply it to a real world problem, right? So when it comes to a real world problem, you don't have to solve for a complete triangle. That's why I put in here, you don't have to solve for it completely. You just have to solve for whatever the question asks you, okay? Sometimes the question will ask you to solve for like a specific side or a specific angle, but you don't have to solve for like all 3 missing data, okay? So for example, let's do our first example on the left hand side. The navigator of a ship at sea spots 2 lighthouse that she knows. Okay, let's read it like silently. Okay, and after that, okay, to my habit, I usually like circle on the datas that I have from the problem to make sure I use them up, because at this level, if you like miss out on data, it's not tricky. So it means that you're missing something, you're missing a step or something. So make sure you use up all the data in here. So just to confirm with the diagram that we have in here from the problem, we have 3 datas, right? So from the picture, we should also have 3 datas. We have 3 miles in here, we have 15 degrees and 35 degrees in the picture. That's good. And the question, let's underline the question really quick in here. What do we have? The question asks for how far is the shift from the lighthouse P. So this is the shift. This is lighthouse P. We're looking for this distance from here to here, right? So let's call it X. My pen is capitally smearing. I don't know why. Let me erase it and draw it again to make it easier to look at. Here, this is what the question asking us to find. Let's call it X, okay? We have to find it. Okay, and remember, in this lesson, in this section, we're talking about law of size, right? So somehow we have to use it. So in the triangle formed by PQ and the shift, let's call it S. Instead of using ABC, now we're going to have a system of PQS. But same thing, right? We're going to have like the law of psi in here. So technically we will have 3 pair of fractions. In each pair of fraction, we will have psi of the angle on top and then the psi length on the bottom. And the angle will look across from the psi length, like vertically on the fraction. Okay? So right off the bat, we can calculate the measure of angle S in here. So we do 15 plus 35, which will get us 50. No. So 15 plus 35, that's 50, right? Like in total, this angle will be 50. Let me have like, mark it out like this. So this one in here is 50 degrees. Okay. And what else do we know? We know that angle P in here, we can find it. How can we find it? Angle P in here is in the top right triangle, if you can see. Or let me just put it in green. Like we have two triangle. There's a top triangle like that, and the bottom triangle, let me put it in yellow. Okay, and we also have a big triangle. Let me put it in blue. Okay, so in the top triangle, which is in green, if we notice, we have a right triangle, right? So if one angle is 15, the other angle would be 90. 90 minus 15, which is 75. So angle B in here would be 75. Let me change a marker. Let me change it to blue. Also, I mean green. So big P in here would be 75. Okay, whatever. And then with the same logic, how can we figure out big Q, right? So for the yellow triangle, it's right triangle, right? It's a right triangle. So with the same logic, we would do 90 minus 35, which is 55. So we know all the angles now, and we have like the side opposite to S, to the angle S being 3. So now we can set it up to find X. How can we find X? We will use angle Q, right? So if you notice, we will have something like psi of S divided by little s equals to psi of Q divided by little q. Okay, our s in here would be 50. Little s in here would be 3. So let me put it together. Let me write it in yellow. So we have psi of 50 divided by 3 equals to psi of big Q in here is 55. And then the little q in here would be, oops, sorry. And the little q in here would be X. So we got this step in here. Okay. And then how do we do it? Wait, I think I have a typo in here. Give me 1 second. Let me just think about it really quick. Yeah, it's definitely a typo. Yeah. So this one in here, it shouldn't be 75. It should be 55, okay? So go with this equation. Don't go for the key, okay? And I think my answer should be wrong too, because this one is like 55, not 75 anymore. Let me do it really quick in here, and then I can fix it with you guys. So in this case in here, in this step, we're gonna go ahead and multiply, like crossway. We'll do cross multiplication. So we have something like x times psi of 50 equals to 3 psi of 55. And then if we punch in the calculator, 3 times psi of 55, 3 times psi of 55 divided by psi of 50, then our final answer should be 3.21 mile. Let me box it. Okay, so ignore my answers in here. I will fix the key and I will repost it after this. But technically this is how it goes for this one, and I want you guys to try this example really quick in here and try it, and please let me know if it works. Okay, if you have any question, let me know. Okay, and as for the last page in here, this one is just like the interesting formulas that I scraped out from our textbook. It's from the homework section. Okay, it's just for fun. Like if you're gonna go to like physics classes, and if you go to like calculus classes, you might need to know these formulas, especially this formula right here, or this formula in here. Even like you might need to know it. And as a common sense, since we know the law of psi, we will learn about law of cosine in the next section, and we also learn about law of tangent. But since like law of tangent, it looks like this, right? Like you can tell it's horrible already. So we're not going to learn it in this class, but it's just like, it's for fun. Again, if you want to read it, you can go ahead and read it. It's from our textbook. But you don't have to use any of these. You don't have to memorize or understand any of these formulas, because I'm not going to test you on either quizzes or tests in our class. Okay? So thank you very much for listening. Thank you.